got a problem for us to try up here. I'm asking us to plot this point, 1, 3 pi over 4. So 1 is my r value, and 3 pi over 4 is my theta value. Okay. Let's actually just do that first. So 3 pi over 4, that's going to be the ray that determines the positive direction. So from here, I'm going to rotate 3 pi over 4. So that's going to be pointing up and to the left. Okay. All right. Then my r value is 1. That's positive, so I've got to go in the positive direction, which is up and to the left, and I've got to come up 1 unit. So I'm saying here that this distance is 1, and that's my point right there. Okay, so we've successfully plotted it. Then we're also asked to find 2 additional polar coordinate representations. So different polar coordinates, but of the same point. And we're asked to do that twice. In part A, we're finding 2 where the r value is positive, and in part B, we're finding 2 where the r value is negative. Okay. So, for part A, if the r value is positive, it's going to be 1. Okay. Remember, the r value, we've only got 2 choices. It's 1 if we're going in the positive direction. If we were going in the negative direction, it would be negative 1 instead. Okay. So I need other angles that also make this the positive direction. So I basically just need angles that are coterminal with 3 pi over 4. Okay, I can do that. Let's do 3 pi over 4 plus 2 pi. I'm just going to work that out over here, and then I'll fill that in here. So that would be 3 pi over 4 plus 8 pi over 4. That would give me 11 pi over 4. Beautiful. Now, if I want another point, I could add another copy of 2 pi. So that would be essentially adding another 8 pi over 4 to get me 11 pi over 4. I'm going to actually instead do 3 pi over 4 minus 2 pi. Okay. That's also coterminal. Remember, I can add or subtract a multiple of 2 pi. Well, I'm adding a multiple of 2 pi. That multiple could be positive or negative, and I will get a coterminal angle. So this would be 3 pi over 4 minus 8 pi over 4. That would be negative 5 pi over 4. That works. Those are not the only 2 possible answers. Again, this could be 19 pi over 4. I could add 500 copies of 2 pi, or subtract 3,000 copies of 2 pi. I would have a coterminal angle. So there are infinitely many options here. These are just among the simplest. Okay. Now for part B, we want to do this with a negative r value. Well, if my r value is going to be negative, it's going to be negative 1. Because what we're going to do is we're going to say we want to define this to be the positive direction, so that when r is negative, we go in the diagonally opposite direction, which is defined as the negative direction for that. Okay. So let's see, if this is 3 pi over 4, that would make this angle right here pi over 4, which would make this angle right here, just the absolute value of that, the amount of rotation, would also be pi over 4. Okay. Because remember, anytime you have intersecting lines, the angles that are opposite each other, we call those vertical angles. Vocabulary isn't so important as knowing that the angles that are opposite each other are the same. Okay, so this angle here is pi over 4. This obtuse angle here would be 3 pi over 4, same as that one. Okay, so basically I could get here by rotating pi over 4 in the negative direction. So I could have theta be negative pi over 4. Do notice pi over 4 here was just representing how much rotation I had. I want to make sure that I'm not rotating pi over 4. I want to make sure that I'm rotating negative pi over 4 so that I land in quadrant 4. Okay. I could also get here by rotating almost all the way around. that would give me 2 pi minus pi over 4. That's 8 pi over 4 minus pi over 4. That would be 7 pi over 4. So here are two polar coordinates for this point that have a negative r value. Now, I happen to have chosen, in both cases, one positive angle and one negative angle. That wasn't part of the directions. That was just my choice. Okay. What I'm going to have you do now is I'm going to keep these directions the same, but I'm going to change the point for us. Okay. So I'm going to have you plot -3, let's go with -5 pi over 6. Okay. So I want you to pause the video, plot that point, and then find 4 additional names for that. 2 additional names where the r value is positive, and 2 additional names where the r value is negative. So go ahead and pause the video, give that a shot. Okay, so let's start with plotting the point. I'm going to start by drawing the ray that determines my positive direction. So since my angle is negative, I'm going to rotate -5 pi over 6. That's going to be just shy of -pi, because that would be -6 pi over 6. If I want to, I can remind myself of that. So -5 pi over 6 would look like so. So that ray is determining the positive direction, and then the opposite direction is, of course, the negative direction. So now my r value is -3, so I want to come 3 units away from the pole in this direction. Instead of going left and down, I'm going up and right. So 1, 2, 3. I'm sort of deciding on a scale here. But in doing that, I'm saying that distance is 3, and my r is -3 because I went in the negative direction. So there's my point right there. Okay. Now, in finding additional names, I'm actually going to do part B first, okay, with r being negative, because r is already negative. So these points would just keep that same r value of -3, and I just need a theta value that was coterminal with -5 pi over 6. Okay. And I think the simplest way to get that is just to add a 2 pi to that. So if I did -5 pi over 6 plus 2 pi, that's -5 pi over 6 plus 12 pi over 6. That would be 7 pi over 6. Sorry. Had a brain fart for just a moment. That would be 7 pi over 6. That would be if I rotated in the positive direction to this ray. And if I wanted to get another angle, I'm just going to add another 2 pi. So I'm going to add another 12 pi over 6. That's going to take me to 19 pi over 6. Excellent. Okay. Now let's go ahead and do part A. So for part A, we wanted 2 names, but where r was positive, so it's going to have to be 3. Okay. The distance is still 3, and so I need a number whose absolute value is 3, and there are only 2 of those. But now I want an angle that's going to point in this direction. Now, if this was -5 pi over 6, this angle right here would have been pi over 6, which makes this also pi over 6. So that acute angle, pi over 6, I think is definitely the simplest one that makes this the positive direction. And then if I want something coterminal with that, I can add or subtract some number of 2 pi. I'm just going to add 2 pi, and we've already seen that 2 pi was 12 pi over 6, so 13 pi over 6 would work. Now, these are not the only answers. I think these are probably the simplest answers that we can get for this particular problem, but there are infinitely many names in polar coordinates for a single point. Kinda cool.